Back to Live with AI Virtual CES 2022, a webcast series featuring exclusive interviews with industry experts and thought leaders on the topics of ADAS and autonomy, as well as virtual demonstrations of AI CES Innovation Award winning Foresight LiDAR, a software centric and solid state solution that adapts and optimizes its scan patterns in real time. These broadcasts will be airing across any and all of AI's social media platforms, including Facebook and Twitter, as well as LinkedIn and YouTube. You can follow us there to get notified when each broadcast begins both today and tomorrow. All of the interviews you see with the industry experts over the next 2 days will be archived at a later date on AutoVision News. Our next guest is HanBin Lee. He is the CEO and co-founder of Seoul Robotics, where he oversees the company's work developing vision software for 3D sensors, including LiDAR. HanBin started Seoul Robotics from a small office in Seoul, South Korea, in 2017. And since then, he's brought the company to the world stage, cultivating partnerships with a variety of global customers, including BMW, Mercedes-Benz, Volvo, and Qualcomm. HanBin is also known as Cap, or the Captain, among his employees, peers, and colleagues. Please welcome to the program today, the Captain, and so good to have you with us, HanBin.
Having me. It's wonderful to be here on the AI's CS virtual conference.
Yeah, absolutely. And you are at CES right now demonstrating your perception solutions. In fact, we actually just saw a demonstration video just a moment ago. So tell us about the show at CES and tell us what you're showing there at CES.
Yeah, so we actually prepared a lot with together with AI at the CS to demonstrate the system in real time to basically show how our software and AI's LiDAR can identify and track different type of objects, starting with the pedestrians, but not only
Sure.
pedestrian, but things like bicycles and vehicles, different types of vehicles. So I'm kind of bummed out that we cannot show this live to the crowd with
Me
such an
too.
exceptional lidar that AI
Me
has.
too.
But that's what we do, and we have the perception capability of tracking the objects to the close to 4 centimeter accuracy, which
Hmm.
is which is phenomenal compared to other sensor modalities out there.
Right.
But that's what we have briefly shown at the video um, prior to this live cast.
Right. Now, Captain, on your website, there are some key areas listed under the Solutions tab. So I'll just go through them briefly, but obviously autonomous vehicles and ADAS, smart cities in industrial. So can you tell our viewers about your solutions and, how are you active in each of these areas?
Yeah, so our company started off. Our first client want us to build the lidar perception software we call 3D computer vision for
Okay.
their self-driving cars. So that's
Sure.
where we all began, trying to build a high-performance, extremely accurate, real-time 3D perception software for the lidars. And so, and then from that point on, we realized that the lidar performance as well as the price was coming down pretty rapidly, so that the ITS, the smart city industry, was willing to start integrating and testing the lidars for their applications. And and before I go more into what other um, kind of product verticals that we have,
Sure.
um, I I want to talk about how the differences in modalities required for many different things, not only for autonomous driving, but for smart cities as well. The reason why the LiDAR is being adopted widely in the smart city industry is because the the smart infrastructure industry already knows how radar works, and a lot of times they know how the camera works, and LiDAR is filling the vacuum in between. Uh, to
Yes.
be more specific, the radar is pretty good at detecting object speed and how far they are, but they often fail to understand where the people are in the smaller objects. And the camera, while they're good at understanding like the license plates or the types of vehicles, they often can't figure out where the things are exactly. And LiDAR can effectively figure out, again, with our software capability, understand every single object's location within 4 centimeter accuracy. And this is where you can understand the people and vehicles locations extremely accurate, and that this is where uh, then a lot of the pain points are being solved with the LiDAR systems. So going back to our product stack, we start with the
Right.
AV and ADAS, and we spend a lot of time with the smart city industries and industrial, where it's kind of similar to smart city, but understanding the like pedestrians indoor, such as retail space, especially in Europe, where the private personal information, like a facial information, is very critical, and they
Yeah.
don't want it to be shared to the public. Where LiDAR is, it's really good in a sense that we know where people are, but we cannot identify who they are.
Sure.
So this is where in Europe it's being widely, the technology is being widely accepted. And then last and not the least, the product stack that we have is called Level 5 Control Tower, which is essentially taking putting the sensors and the lidars on the infrastructure and helping them to drive autonomous vehicles using V2X systems.
Yes.
So
Yes.
yeah, it's a natural progression of our software, where we started with the automotive software, and we went to the infrastructure lidar solutions, and now we're using that information, basically going back to the vehicle by helping them to drive more safely, assisted by the systems that is installed around the vehicles, not on the vehicle.
There is a line on your website, Captain, and it says this: as Microsoft Windows is to desktop computers, Seoul Robotics sensor will be to LiDAR. I
Yeah.
love that line. So, why is it important, Captain, for LiDAR to have 3D vision software like sensor?
Yeah, so this is kind of our pitch line to the investors as well. The
Sure.
windows to your LiDAR. Um, so two component is really required in order to have a fully functioning LiDAR solution for different industries. Obviously, the
Hmm.
first component is that you need to have a high performance LiDAR. When we say high performance LiDAR, you need to see farther and the resolution needs to be great. Second part is understanding what those raw data means to clients, and each vertical requires different type of object identification. For smart
Sure.
city, it's most often that it's more important to understand the people's location, because they're called the vulnerable road users,
Hmm.
and to prevent the vulnerable road users from um, becoming endangered by a different type of wrong traffics that are not meant
Sure.
to, the traffic violators, to
Hmm.
be specific.
Sure.
and
Sure.
and for autonomous driving, understanding the vehicle's location, especially in the accurate manner of predicting where they're going to go, is more important, as well as understanding the
Yes.
curbside, which is it's difficult to understand where exactly the curbsides are with the cameras, but with lidar you know exactly where they are, how far they are, how high they are, so things like that. So the without the extremely detailed high resolution range raw data, the software cannot process and extract meaningful informations from the sensor itself. So it's again, it's like it's one if it's great to have a high performance computer, right? But for most
Oh, sure.
people, you need to have either if it's an Apple product, it comes with a lot of OS. If it's Windows product, it comes with
Hmm.
Intel. So the great hardware requires great software for the end user to benefit mostly from the package solutions.
Right. So more of a broad question overall, but I have read and heard some things that that lidar isn't essential, or that people don't believe in lidar, or they believe that they can do it without lidar. So, I
Hmm.
mean, for our viewers watching today, Captain, why is
Yeah.
just LiDAR in general, why is it a necessary technology to, usher in future mobility and to have all of these smart city applications like you're talking
Hmm.
about? Why is it an essential technology?
Yeah. Well, it's the sensors have been, I believe, evolved naturally nowadays from 2D sensors to 3D sensors. Um, and I want to talk about going back to camera days. When the
Please.
first
Yeah.
digital camera was introduced, first digital cameras were super expensive. It used to be $100,000, $10,000. Even back in
Yeah. Yeah.
'94, if you want to have a personal digital camera, this thing was of very for rich people.
Sure. Sure.
It's and and people thought consumer market for digital camera it just doesn't make sense because the things are so expensive. And I
Right.
think LiDAR it's going through the same pattern when it comes to pricing. But now going back to if is the technology
Yeah.
essential? So if you look at the robotics market, I don't know of single HV robots or indoor delivery robot startup that does not use some sort of a 3D sensors.
Sure. Sure.
Because
Sure.
understanding depth, not just the color information, understanding the raw depth information is essential because you need to know where things are in order to navigate. Now, there are folks who are trying to understand the 3D vector space directly from the 2D camera informations, and it's like why why do you need to do that when there's already available pretty reliable and economical 3D sensors out there? And as I said, since almost all indoor robotics are having some sort of a 3D sensors. Sometimes they're LiDAR sensors, sometimes they're not. But they don't. You don't have to see far because these robots only drive maybe 3 miles per hour. Now
Okay.
let's
Right. Right.
expand that information to the vehicles. The vehicles do not drive 3 miles per hour. It drives sometimes 80, 100, 120 miles per hour.
Yeah.
It just needs to
Yes.
see far. And the understanding of the 3D scene is it's the same for delivery robots that drives 3 miles per hour, or the self-driving car that drives at 120 miles per hour. And
Hmm.
it's understanding of again precise locations. It doesn't with the current technology, the radar cannot provide 4 centimeter accuracy of object information. It's usually within plus minus like 3 meters to 5 meters. Again, for some application that is good enough, but for some application it is not good enough. And cameras are usually pretty good at again understanding the color information, but when it comes to object location information, it could vary as bad as maybe 20 meters or 10 meters accuracy, which again is it could be good. It could be good enough for some applications, but for some applications not. So just again, I think the lidars are filling in the gap of the depth information, the accurate depth information that is required to make the autonomous driving or smart ITS solutions that provides value to the cities, to our daily lives, for safety of vulnerable road users and other vehicles, is why I think that the lidars will be essential now, is essential now, and will be essential in the future. And I just don't see how, with all this investment and advancement of the technology and especially pricing coming down. When I first started, the 16 channel lidar was, oh, I think that's still $12,000. Now a 16 channel
Yeah.
LiDAR is close to $1,000, $2,000. I know
Right.
AI is
Right.
it's super dense. I don't even know how many channels they have vertical. But
Hmm.
it's yeah. I think the technology will be pretty uh, universal across many different type of
Right.
industry, not just the self-driving cars, but again self
Right.
ITS industrial use cases.
Which we're seeing as part of this broadcast series, Captain, is, there's just obviously automotive comes to mind first, but you've got trucking, ITS, as you've
Mhm.
mentioned, rail, which is another area that AI provides a number of solutions for. And speaking of AI, you have an important partnership and you have an important relationship with AI. Let's talk about that a little bit. Fill our viewers in on your working with AI.
Yeah. So we can't we've been we known AI for quite some time, but starting last year, we really start delving into the ITS market together because there are two components to, well, I guess three major components to the AI LiDAR that makes it attractive to the ITS industry. First of all, it's high resolution LiDAR. Again, we started with 16 channel LiDAR, means that vertically there's only 16 pixels that you could see from what the LiDAR we're using. Currently, I have no idea how many channels the vertical resolutions of the AI LiDARs are, but it's pretty dense. Second of all,
Mm-hmm.
it's extremely hard to find a long range LiDAR that is affordable. With our software and AI's hardware, we can, I think, see somewhere between 250 meters to even up to 300 meters, which is as good as some radars out there. And now there are radars that see further, and they're a lot more expensive than the
Mm-hmm.
what the typical ITS solution providers can afford. So right now, what we are seeing is there are radars being deployed in the highway scene because of the long range requirement, and AI's lidar is actually is almost competing in that space with the radars, but again, except with more resolution and more extreme accuracies that the radars cannot provide. And the third thing is the reconfigurable scanning pattern. We can choose to
Right.
focus on specific areas. Now, for our applications for ITS, we don't really need a dynamic beam configuration in real time. But what's really useful is that when we install a LiDAR, let's say on the highway or on a city, we
I
want to
follow
make
you.
sure the particular area is focused all the time. So we will maybe drop some scanning pattern on the top side of the screen and rather focus on nearby the ground where it's right below the lidar, because maybe that's where the pedestrians are, for the vulnerable road users. Maybe on the highway, we rather want to focus on the object on the far away, because the goal is to see as far as possible, and we're not too concerned with the object that is nearby. And this kind of technology is not really available by the other lidar vendors. It's usually you have to go physically change the angles of the lidar to make sure it's optimized, and if it's somehow tilted or misconfigured, you have to go there and physically change it. While with the AI lidar, you might not need to do that. You just might need to reconfigure the scanning pattern by the software, and which could save a lot of cost when it comes to reconfiguring the system. Um,
Last question here, and I because I think that our viewers will think this is really neat. Tell us, Captain, how did Seoul Robotics start? Tell us a story of the company. The story is on the website for our viewers who want to see it later. But tell us in your own words how the company started.
Yeah, so we started in 2017, right after a Silicon Valley self-driving car competition where you're supposed to use radar, lidar, camera all together to basically identify the surrounding as accurate as possible.
Mm-hmm.
And and our team decided to do. Well, I said, well, why don't we just use lidar, since everybody's gonna do sensor fusion and other sensor modality, just to see how far we can go. And out of 2,000 teams, we ended up in 10th. And after that, we got a lot of calls and offers from other self-driving cars asking us to
Sure.
join them to make LiDAR software for them. And I thought, well, why don't we build a company and supply the LiDAR software to all these companies, because there seems to be so much demand for perception software for 3D sensors, especially for long-range LiDARs. And that's how we began, and that's why we our first software was for the self-driving cars. And then the premise and the name was Seoul Robotics, because we realized that this perception software is not only for the vehicles, but it could be utilized for different robotics as well as, who knows where the LiDAR will go, and that was the premise of the company, and the four co-founders are still together. I don't know if the board together. It sounds like we're married and we're not divorced yet or something. But the startup is like kind of marriage
Sure.
between many
It is a
companies.
family. It is.
Yeah, yeah, yeah.
It
So
it
that's
certainly
how it
is.
began, and the name Captain stuck with me because that that competition group required a captain to kind of communicate and submit different
Yes.
type of things to the competition, and
Yes.
yeah, stuck with me since
Indeed.
then.
Yeah, it's a fitting nickname, Captain. And thank you for joining us today and being part of our broadcast. From all of us here at AI and AutoVision News, we want to wish you the best of luck going forward. And again, thank you for being with us today.
Yeah, thank you for having me. Have a great rest of the show.
Yes, enjoy CES as well. How can you leverage adaptive LiDAR for industrial applications, and what role do system integrators play? We will discuss that in our next live stream, which begins at 10:30 Pacific and 1:30 Eastern. Now, you can join us live through any and all of AI's social media channels, including Facebook and Twitter, as well as LinkedIn and YouTube. If you go to any of those pages, you can get notified of the next broadcast, which should begin here in about 10 minutes. This is Live with AI, virtual CE